Hello friends, welcome to Physics Online. We had just a few days back done dual nature. We'll do a few exercises in this particular chapter. The first one over here is quite simple. They are asking you the frequency of a photon whose energy is 6.63 electron volt. So what is the formula for energy? Energy is E is equal to H into mu, and E is given in electron volt. What you get by h mu would be in joules, so that conversion is a very important thing. So E is 66.3 electron volt multiplied by 1.6 into 10 raised to minus 19 will give your energy in joules. Frequency is energy upon h, because energy is h mu. Putting the value, get 1.6 into 10 raised to 16 hertz. That's the frequency. The second one, it's same. We are given the wavelength and we are supposed to find the energy in electron volt. So here what we do is we write the value of mu or frequency in terms of wavelength. Frequency is c by lambda, so energy will become hc by lambda. So this is energy, and then we have to convert it. Now this is in joules, so we have to convert it into electron volt. So divide it by 1.6 into 10 raised to minus 19. Do your maths and you'll get the value. Go to the next one, read this sum. So here you are given monochromatic light, its frequency is given to you. You are given the power emitted. Power means energy per second, that is joules per second. So he is asking you first of all what is the energy of the photon. That should be given by h mu. That's quite straightforward, nothing much to do in that. The second part over here is important, and that is he is asking you the number of photons per second. So the way to do it, first you find out, like you try to find out the value of energy. So you will get the value of energy here. So your energy E will be equal to H into mu. So it will be equal to 6.63 into 10 raised to minus 34 into 6 into 10 raised to 14 hertz. So that's the energy. That's the energy of one photon. So this is the energy carried by one photon. Now he says that the power of the light is 2 into 10 raised to 3 watt. That means 2 into 10 raised to 3 joules it is giving in 1 second. So the energy given by it in 1 second, that is the energy per second, will be equal to 2 into 10 raised to minus 3 joules per second, and one photon energy is this much. So number of photon will be equal to total energy divided by energy of one photon. Total energy of one photon. Total energy is how much? 2 into 10 raised to minus 3, and we will divide this by 6.63 into 10 raised to minus 34 into 6 into 10 raised to 14. Okay, put your calculations together and you'll get the answer. So this has been worked out for you. So first of all, we get 3.98 into 10 raised to minus 19 as the joules. So total energy supplied by the energy of one photon, we get the number of photons. Okay, now let's go down to the next sum. Work function of cesium is given as 2.14 electron volt. Okay. Threshold frequency we have to remove, and then we have to remove that wavelength of light. Correct? for which the stopping potential is 0.6 eV. So we have to basically find out the kinetic energy of the electron. So first of all, work function we'll figure out. So 2.14 into 1.6 into 10 raised to minus 19 will be in joules. That should be equal to H into threshold frequency. So your threshold frequency will turn out to be 2.14 into 1.6 10 raised to minus 19 divided by 6.63 into 10 raised to minus 34. Okay, so that will give you your answer in frequency. So ये मिल गया. Now he is given you the stopping potential, that is this much electron volt. So this is the energy. Now you have to find out the wavelength. So let us say that the wavelength is lambda. Now the energy coming out from the photon will be h into mu, which can be written as hc by lambda. We know that this will be equal to the work function and plus the stopping potential EV, correct? So first of all you find hc by lambda, we don't know. Hc you can multiply. Work function we just worked out, it happens it's given in electron volt as this much. So 2.14 plus 0.60 EV. So total energy that we need is going to be 2.74 electron volts. And H is 6.63 into 10 raised to minus 34 into 3 into 10 raised to 8 is the velocity of light upon lambda, which we don't know. And now we have to convert this into electron volts. So we'll have to divide it by 1.6 into 10 raised to minus 19. Doing your arithmetic, you'll get the value of lambda. So we got the value of frequency 5.16 into 10 raised to 14. In case the rolling is quite fast, you can always pause and look at what things are. And in the next case, as I told you, we are looking at your kinetic energy, which should be equal to hc minus work function should be EV. So your lambda will be hc upon this. Put all the values and you will get the wavelength as this much. Do your maths properly. Okay, let's go to the next part, next question. Rather lengthy question. I'll read it. So in this case, he is saying that we have used ultraviolet waves. We are given the wavelength as 300 nanometer. Nanometer means 10 raised to minus 9, or you can write it as 3 into 10 raised to minus 7. The minimum negative potential, that means the stopping potential is 0.54 volt. First he wants to find out the energy of incident photon, that will be hc by lambda. Maximum kinetic energy of the emitted photon will be equal to half mv square, should be equal to E into stopping potential. So 1.6 into 10 raised to minus 19 into 0.54. So once you get that, then you can subtract the 2 to get work function. So see, first we are given lambda, which is converted into meters. We put it in hc lambda, we get it in joules. We convert it into electron volt by dividing it by 1.6. So now we know that the energy of one photon is this much. Maximum kinetic energy will always be equal to E into V, so it will be equal to 0.54 electron volt. So now E max will be equal to h mu minus mu 0. So your work function will be equal to h mu minus this, will give you 3.6 electron volt. Next question, very similar one. They have given you wavelength, they have given you the work function. So first you calculate hc by lambda, convert it into electron volt. Then secondly, subtract the work function from the energy of the photon, you will get max kinetic energy. Divide that by 1.6, you will get the stopping potential. So we are given lambda, we are given work function. First you convert this is in joules. So when you convert this into electron volt, you get 2.4825 electron volts. So subtract 1.9, you will get the maximum kinetic energy. So maximum kinetic energy is this, and that should be equal to E into V0. So V0 will be equal to maximum kinetic energy divided by the charge on an electron, and that will come down to this much. Let's go ahead and see another sum. Okay. Here we are given a graph basically of stopping potential versus frequency. The slope of this graph will essentially give you the value of h upon E. So slope should be equal to h upon E, and from that you can calculate h because E ka value is already known to us. So the slope of this graph or the gradient of this graph, whatever you call it, is equal to h upon E. So your h will be equal to gradient into E, or in our terms you can write it as slope into E. That will give you the value of h. So you got this. So 8 minus 5 essentially is the difference in the x. Okay. What they have taken is they have taken this 8 value and they have taken 5. That actually has come from this part. Okay, from the x axis, and y is 0 to 1.23. ऐसा आ गया. So this is h in joules second, and when you multiply it to 1.6 you get 6.56, slightly different, slightly on the higher side. Read this sum. So you are given two graphs here, one is P and one is Q. Now as you know, the slope of each of the graph will give you the value of h upon E, and the intercept will give you the stopping potential. So he says which of the two will have a higher threshold for frequency. Higher threshold frequency will be Q because it is 6. So intercept jo hai, whenever it is the intercept with the x axis is 6, so Q will have a higher potential and this will be around 3. So that should be. Now determine the work function of the metal which has the greater value. So we are given the frequency, that is 6 into 10 raised to 14. You multiply it with h, that is 6.68, you will get the work function. If you want it in electron volts, you will have to convert that into electron volts. Having obtained that, you have to find out the maximum kinetic energy of the emitted electron emitted by the frequency of light. So frequency is given, so h mu is the energy of the photon, subtract the work function, you'll get the maximum kinetic energy. So we know that this is the threshold frequency of Q. Its work function will be h into this. This will be in joules. To convert it, you have to divide by 1.6. 2.5 is the stopping potential. Using maximum, we'll get h mu minus mu 0. You are given that value of mu is 8 into 10 raised to 14. So 8 minus 6 will give you 2. So you'll get 2.8 minus 6 will be 2. So you get the maximum kinetic energy as this. So we come to the end of this session. In the next session, we look at the exercises in matter waves. Till then, thanks for joining and have a nice day. Do take good care of yourself. Bye.